Hello dear student, good afternoon. Yesterday we had seen the casting, die casting, hot chamber casting, cold chamber die casting and casting furnaces. In today's lecture we are going to discuss about the casting defects. So these are the undesirable results from the casting. Those are not where you need to produce a defect. So we are going to avoid it by proper following the procedures and following the some rules. So, what do you mean by casting defect? Casting defect is nothing but an irregularity in the metal casting that is undesirable. So, some defects can be tolerated and some are repaired. Otherwise, all casting defects are eliminated by following some procedures and some rules. So, an unsuccessful casting results in considerable trouble and loss of time, loss of labor cost, and like that. Some casting defects are large in nature, so products can be rejected because of casting defect. Those are not repaired or reworked; those are rejected because of this casting defect. So, casting defect can be avoided strictly by observing the procedures which are governed by certain fundamental rules and principles. Casting failure should be an exception and not the rule. Casting failures should be an exception. It can be repaired, it can be reworked, it can be avoided. So, there are various types of casting defects. First one is blowholes, pinholes, seat, core seat or cope and drag box seat, then short runs, hot tears, cold shirts, etc. So these are the casting defects. These are the various undesirable defects. So one by one we are going to discuss. So major defects are because of gas, because of this in case metal property, molding material defects, some sand materials are there, pouring metal defects, the temperature of the pouring metal or the properties of the pouring metal that also alter the casting defects. And mold seats. There is a shifting or misalignment of the molding box. So gas defects means trapping of the hydrogen or carbon monoxide gas in the mold cavity or in the molten metal. So that will create a blowholes, porosity or pinholes. So these defects occurs due to the dissolution of hydrogen gas. Gas entrapped during heating or during pouring of the molten metal inside the mold cavity. So these are the various effects. If you look these are the casting products. This is the flashlights. These are the flashlights. So this will happen after casting. This is the mismatch. This above portion, this one, above portion is carried out in the cope box, and this is the below portion is carried out in the drag box. So there is a misalignment in this two. So that's why it is a mismatch. Now, if you observe this cold shut, misrun, blowholes, and gas porosity. So this cold shut means here. Then this is the misrun means no metal is filled in this portion. Blowholes means this is the blowholes, and this is the gas porosity or inclusion of the sand particles in the material. So these are the various casting products and these are the various casting defects. This is the shrinkage cavity. This cavity will shrink. This will also shrink. some dispersion and some shrinkage. Then porosity. Porosity means these parts will remain porous in this portion. Then shrinkage or sink. This portion, you are observing that this will sink, shrinkage. Then corner shrinkage. We observe this metal is shrinking. The corner is shrinking. We observe this crack. After casting, you will have this particular crack after casting. So this is the crack formation. So these are the various distortions or various defects after casting. So this is the scar. This is the casted product, and some portion is left. In this portion, no metal is filled up. So this is called as a scare or scar. Due to improper permeability of sand or due to improper venting. Venting means you are not carrying out the proper ramming or you are not escaping the gases. Venting is not carried out properly. So this shallow glow comes into picture after casting. So it generally occurs on flat surface, whereas glow occurs on a convex casting surface. A blister is a shallow glow like a scar with thin layer of metal covering it. So we will observe in this case. This is the shrinkage. Metal is shrink in this case. This is also shrinkage. This is shrinkage. So this is the casted product having casting defects. This is also glow holes. These are the porosity. So these are the casted product and casting defects there. Now this is the convex surface. This is the glow casting defects. This is the flat surface. On this there is a scar defect, and this is a flat surface, but this defect is called as blister. And this convex surface, on this you are obtaining scab. This is wash or drop is also called as, or swelling is there. This is swelling. And this is mishran, means you are pouring the molten metal reaches up to this. Rather than to reach at this end, it reaches to up to this portion. So this is called as a mishran. Cold shut is that the metal is not reaching to this portion and this one. This is called as a cold shut. Means previously it is solidified at this end. When molten metal reaches to this portion, it will solidify at this end, and this portion is not filled up with the molten metal. So such type of defect is called as a cold shut. Now mishran and cold shut. So in this diagram, this is called as a mishran. Means you are pouring the molten metal through this flue. It fills the mold cavity, but it not reaches to this end. It reaches up to this and solidifies at this end. So such type of defect is called as a mishran. Means when the metal is unable to fill the mold cavity completely. The mold cavity is not filled with the molten metal. Use some unfilled cavities. It is called as mishran defect. So this portion is not filled up with the molten metal. So this will remain, means molten metal solidify at this end, and it will not, this cavity is not filled with the molten metal. So such type of defect is called as a mishran. And then this cold shut. Cold shut means this portion will indicate the cold shut. So when two metal streams meeting in the mold cavity do not fuse together properly, causing discontinuity or weak spot inside casting, it is called as cold shut. Now look this diagram. Molten metal comes to this portion, it follows the portion, it also follows this path. So it will come from this end, it will also come from this end. When these two reaches to each other, they will not diffuse. The molten metal from this path and from this path, those are not diffused, or those are not mixed up. with each other. So some cavity will remain, that is called as a pole shut. So discontinuity or weak spot inside casting, it is called as pole shut. When two metal strips meeting in the mold cavity do not fuse together properly, causing discontinuity or weak spot inside casting, it is called as cold shut. So some such type of defects are called as a cold shut. Shrinkage cavity. Shrinkage cavity because of the metal property, molten metal property. Shrinkage cavity is a void on the surface of the casting, caused mainly due to uncontrolled and haphazard solidification of the metal. The molten metal coming from this screw, passing through weight and filling this mold cavity. But due to solidification of the metal, some portion will left, and this will called as shrinkage cavity. Means after filling this portion will shrink and it will void is there. Some open space is remain there. This is the open space. This is called as the shrinkage defect. Shrinkage defect may be external. This is external or this may be internal. So these are the shrinkage cavity. Now blowholes. Blowholes means some this portion. This portion is the blowholes. This is also the blowholes. This is the casted product. This is the casting procedure. This is the screw pouring basin from where you are pouring the molten metal when it solidifies. So some holes you are going to see the holes inside the casting. So that is called as the blowholes. So balloon-shaped gas cavities caused by release of cold gases during pouring are known as blowholes. The blowholes are caused because the gases are entrapped during solidification. There are many reasons why this blow comes into picture. So, what are the causes? Ramming is too hard. You are ramming the sand, you are pressing the sand by applying more pressure. Cores are not sufficiently baked. Cores are also not sufficiently baked. Moisture content in the cores, that will also excess moisture content in the molding sand, low permeability of the molding sand. Yes, it will not escaping the whatever the moisture or gases content in the sand. Those are entrapped. Excessive thickness of sand grains, rusted chilled chaplets and inserts. These are the various tools used in casting process. Presence of gas producing ingredients. Some ingredients are also responsible to produce the gases during solidification of molten metal. So that will show us the blowholes inside the casting after solidification. So what are the remedies? Carry out the proper baking of pores. Control the moisture content in the core sand and molding sand. Use of rust-free chaplets, insert and pre-chills. Provides adequate venting so that you can escape the gases from the molding sand. And ramming the mold laser hard. So these are the various remedies so that you can avoid the casting, this blowholes casting. Then porosity. Porosity means this is also just like the some porous portions after casting. You are getting this porous portion. So this is called as the porosity. These are in the form of some cavities caused due to gas entrapment during solidification. Gases are also entrapped. You are observing the blowholes, and similarly small holes are there, or small different rectangular, square, some irregular holes are there. So those are called as the porosity. So what are the causes? High pouring temperature, gas dissolved in the metal, molten metal, less flux is used, and venting is not carried out properly, molten metal not degas properly, slow solidification, then high moisture content, low permeability of the molding sand. These are also same as that of the blowholes. So what are the remedies? Regulate the pouring temperature of the molten metal. Control metal composition. The properties of the that metal should be controlled. Increase flux. This flux is also responsible to remove the gases. Ensure effective degassing, modify heating and drying, reduce moisture content and increase permeability of the molding materials. So these are the various remedies. Then next one is the hot tears or hot crackings. If you observe here, after casting, you are getting such type of tears, hot tears. This is also the hot tears. Here in this case, hot tears. So these are the hot tears. So hot tears are irregular internal or external cracks in the casting. So this is called as a hot tears. So what are the causes? Lack of collapsibility of core and mold sand, hard ramming of molding sand, and faulty casting design. The casting design is faulty. That's why that shows us the hot tears or hot cracks after casting process. So what are the remedies? Carry out the softer ramming, pressure the sand particles properly. Improve casting design and improve collapsibility. So these are the various remedies to be followed. Then you are able to avoid the hot tears at the casting. So metal penetrations is molten metal flows between the sand particles. Penetration occurs when the molten metal flows between the sand particles in the mold. The metal shear starts to flowing in the sand particles. Instead of flowing in the cavity, it also flows in the that sand particles. So this portion is the metal penetration. So after pouring the molten metal, some molten metal goes in the sand particles. Those are called as the metal penetration. After solidification, you will have such type of product. So that product is having some irregular shapes. So what are the causes? Low strength of molding sand, large size of molding sand, grain size of molding sand is large, high permeability of sand. High permeability means more gases are escaped. Those are also responsible to penetrate the metal after casting. So what are the remedies? Use of fine grain sand and with low permeability. Permeability means to escape the property of the sand to escape the gases from it. Appropriate ramming. Proper ramming must be carried out so that you can avoid this defect, metal penetration. Sand is also inclusion. Sand inclusion is also another casting defects. So pin holes. Small pin holes are just like a pins. These holes are seen after the casting. So this is occur because of moisture content, because of impact of the hydrogen and carbon monoxide gas in the metal during solidification, all are not being properly degassed and sand containing moisture and gas producing ingredients. Sand will contain moisture, gas producing ingredients, so those are responsible for the pin holes as a casting defects. So what are type of what the precautions you can take? So reduce the moisture content, increase the permeability of the sand particles, employing good melting and fluxing practices, improve a rapid rate of solidification. So when you carry out this procedure, you are able to avoid this casting defects that is called as the pin holes. So formation of many small gas cavities at or slightly below the surface of casting is called as the pin holes. So these pinholes are comes into picture because of the gas entrapment or because of the moisture content in the sand particles. So this can be avoided if you follow this particular procedure. Then swelling. Swelling, this portion is called as the swelling. This will happen because of the ramming, insufficient ramming. Swelling means what? Enlargement of mold cavity by localized metal pressure. Some pressure, the pouring molten metal, some sand particles acquire this. Some metal goes through this and it will swell. So this portion will be called as the swelling. Swell. So this will happen because of soft ramming. low strength mold and core, and mold not be supported properly. So this can be avoided by sand should be rammed evenly and properly in the strength of mold and core. So this is the swell of the casting defects. Then drop. This is the drop. Drop is a projection on drag part of casting due to fall of its hook part. So this is the drop. This is also casting defect. Low green strength of molding sand, low mold hardness, low strength, and insufficient reinforcement of sand projection in the core. So what are the remedies? Molding sand should have sufficient strength. Provide adequate reinforcement to sand projection and cope by using nails and daggers. So ramming should not be too soft. So this is casting defect that is called as a drop. Rat tails, these are also one casting defects or buckles. So such type of defects if you observe after solidification of casted product, then this is called as a rat tail. So some precautions must be taken so that you can avoid these casting defects. So these are the various 40 years as a casting defect. These are the all the categories of the casting defects. We have seen blowholes, scab, then blister, then gas holes, pin holes, porosity, some drop, then draws also there, dirt also there, then some wash is also there, just like swelling, rat tails, then scab, then buckles, then penetration, metal penetration, then some swellings, swell, then misruns. Means this molten metal is not reaching up to the full cavity, it will not fulfill all the mold cavity completely. Some portion of cavity will be met, that is called as a misrun. When one molten metal passage of one molten metal and another molten same molten metal passage is different. When they are not meeting each other, they are not diffused or they are not mixed to each other. Some portion will left, that is called as a cold shell. Means before reaching to this portion, it will solidify like this. So that is the cold shell. 40 years, there are some crack formations is there because of the solidification temperature. Shrinkage, we had also seen the shrinkage in this portion. Void is there, some space will left. So from this portion, the metal will shrink. Then shift is there, cope and drag box, misalignment in the cope and drag box. So this portion you are casting in a cope box, this is you are casting in a drag box. Those are not aligned properly. So misalignment is there, that is called as the mold shift. And when this is the mold cavity and this is the core, sand core. So there is no alignment in between these two, and that is called as a core sheet. So these are the various casting defects. So these are the various literature about the blowholes. You just read it out. Blowholes are spherical, pattern or elongated cavities present in the casting. They are formed due to the following reasons: rapid evaluation of gas from mold, lack of porosity in the mold box, excess moisture contained in the sand material, hard ramming of sand. Molds, how you can avoid this? What are the remedies? Molds and pores are properly vented, avoid hard ramming, proper amount of moisture in the sand that should be controlled, proper grain size of the sand. So blowholes can be avoided by if you follow this procedure. Then seat, external or misalignment. So core displacement is there, misalignment of cope and drag valves, burnout or burnout of clamping pins, misalignment of two halls of patterns. So these all causes the seat. That is a defect. So what are the remedies you can follow so that you can avoid these particular casting defects? So repair, replacement of dowel pins, proper alignment of pattern, proper alignment of boxes, then repair clamping pins. 40 years. 40 years are crack formations on the surface of the casting. So this will, what are the causes? What are the causes? Lack of compatibility of poor high temperature of plastic metal, incorrect design of the gating system, lack of fillets and corner area. What are the remedies? Properly design the casting, all gate system, improved compatibility, proper solidification and proper pouring temperature. Short run. Short run means the cavity is not completely filled. Completely filled. That is incompletely filled means all the mold cavity is not filled with the molten metal. That is the short run. Insufficient, that we are also calling it as a misrun. Insufficient metal supply. Whatever the metal required, that is you are not using in proper quantity, then that will cause the short run or misrun. Lack of fluidity in molten metal. Lack of fluidity in molten metal. So fluidity in molten metal means it will not flow in properly. So that there is a lack in fluidity of molten metal. Molten metal temperature is low. Before reaching up to its proper destination, it will solidify. It will not reach up to the particular that portion, particular location. So that will form the misrun or short run, faulty gating design. So what are the remedies? Adjust pouring temperature, adjust rate of pouring, modify the gating system. So these are all procedure required to avoid the casting defects, that is misrun or short run. Pin holes, small hole less than 2 mm diameter, which are seen on the surface of the casting. What are the causes? High pouring temperature, gas dissolved in the molten metal, gases are not removed properly from the molten metal, and sand with high moisture content. So these are responsible for blowholes, pinholes, and porosity. So what are the remedies? Maintain the proper pouring temperature, increase flux proportions, so that will help to remove the gases from the molten metal. Reduce moisture, reducing moisture content in the sand and effective gating system. So this is all about the casting defects. So this is in today's lecture we have seen the various casting defects. So what we mean by casting defects? That is undesirable results we are getting after solidification of molten metal. So some casting defects are large in nature, more casting defects are there, so works are rejected. Workpiece after casting, that is rejected, otherwise it is repaired. But if you follow some procedures, then you can able to avoid the casting defects. We have seen many parts after casting. Some blowholes are there, some hot tears, some cracks formations are there, some cavity shrinkage is there, some misrun is there. You are not able to fill the mold cavity completely, that is misrun. So many casting defects were seen. So this is all about the casting defects. Okay, thank you.